back to another visual pattern number talk from visualpatterns.org. This is visual pattern number 354. So by virtue of being a high number, it's also pretty complex, which makes it really, really cool. So I'm going to show you this pattern growth in a couple different ways, and it's really going to help you sort of connect equations in a way that hopefully will be illuminating for you. So let's begin, as we normally do, by looking at the iterations 1, 2, and 3, 1, 2, and 3, and counting up how many, in this case, oranges there are. So in the first iteration, there are 4. In the second iteration, we already begin to see that, like, there's 2 rows of 4 plus 2, that's 10. And in the third row, there are 3 rows of 5, that's 15, plus 3, that's 18. And then we're trying to figure out the fourth iteration, which is hard at first. So let's look at these equations again, or let's look at these images again to see if we can pick out patterns that will help us figure out the fourth iteration. So here we have a 5 by 3, and I'm calling it 5 by 3. It's kind of like a rectangle. And then there are 3 more. And here it's a rectangle of 4 by 2. So it's a height of 2 and a width of 4. And then there are 2 more oranges. And here it's a 1 by 3. And there's 1 orange. So what can you see as a student, or what can your students see? Hopefully they can see that this extra orange at the bottom, or 2 and 3, that is the iteration number, right? There's 2 in the second, there's 3 in the third. So in the fourth iteration, there should be 4 oranges. Okay, now what else do we see? How else can we connect these growing rectangles? Well, I can see this goes 1, 2, 3 as far as the height, and then 3, 4, 5. So it's going up by 1 every time for the height and the width. Okay, well, I can also see again another time that this height seems to always match the iteration number. So I'm going to use that knowledge again and have a height of 4 right here. So the height is 4, and if I think clearly about this, I can see that this number, this width number, is always how much more than the height. It's 2 times more. So if this is 3 and this is 5, this is 4, so then this distance has to be 6. So it's 6 times 4 plus 4. 24 plus 4 is 28. And that's my growing pattern, and I can see, if you've watched other lessons that I have, which you should. Oh, and by the way, you should like and follow me here now for more of these kinds of videos. I have many more of these visual patterns that you can use to either assign to students or show other teachers, to get people to talk about algebra in more deep, interesting ways. So let's get back. And so we can try and determine if this pattern is linear or not. Like it's growing up, we know that the growing number of oranges, but is it a straight growth or something else? Well, every time we go up by 1 iteration, we're going up by 6 oranges, and then 8 oranges, and then 10 oranges. So this fact tells me that it's growing more and more every time we get to a new iteration. The 10th iteration, it has to be, well, it's going to be the plus 10, because that's that bottom part. And then this height is going to be 10, and this is 10 plus 2, or 12. So it's got to be 12 times 10 plus 10. So 120 plus 10 is 130. That's a big leap from the fourth iteration. So it's not going to be linear growth. It's going to go up quicker and quicker as the iteration number goes higher and higher. Okay, so here, what is y equals what in terms of x? This is where the expression goes that we're deriving from this information. Let's do that now. Okay, so we have the x value as this extra number. So there's x, so y equals the x plus the rectangle, right? So this is kind of like the rectangle, which for the area of a rectangle is length times width. So for length times width, we have the x value, length times width. The length is x, and the width is x plus 2. So we have x plus x times x plus 2. This is one way of writing this equation. And if we test it out and plug in like the third iteration, we have y equals 3 plus 3 times 3 plus 2 is 5. So 3 times 5 is 15, plus 3 is 18. That is the value we got for the third iteration. So that equation does work. But I would like to show you another way to think about this that is more closely related to a square. So another way to look at this is take the iteration number and see balance and a center. So what I mean by that is we can look at one and see that there is one orange in the center, right? That is like a square with a length and width of 1, which is the iteration number. And then in here, for the second iteration, there's a square that's 2 by 2. And for the third iteration, there's a square that's 3 by 3. So then in the fourth iteration, there would be a square that's 4 by 4. And now can you see the other obvious connection between what's left and the iteration number? I'm hoping you can. I'm hoping you can see the iteration is 1, there's 1, 1, and 1. So that's the x value 3 times. Here with the iteration of 2, there are 3 groups of 2, then 3 groups of 3. So now there are going to be 3 groups of 4 here. So does that also work for the total number? Let's look at the fourth iteration right here. So 4 by 4 will be 16 oranges, plus 4, 8, 12. 16 plus 12. Does that give us 28? Yes, it does. So this pattern also works. Now, how can I write that equation? It's going to be y equals, well, I have the iteration 3 times. That's going to be the 3x. And then I have x squared, right? Because length times width is just x times x, 1 times 1, 2 times 2, 3 times 3, and so on. So it's 3x plus x squared, which is related to the idea that length times width, if it's the same, it's just side squared. So this equation matches the one that we had previously shown. So check it out. There's y equals 3x plus x squared, and here is the original equation. Do you recognize how they could be similar? Pause it and think about it, because it's confusing. But if your kids can figure this out, they're really advanced, because to see all that and to see it play out in the table, there's a lot going on there. So work with your kids. I appreciate you watching. Please continue to watch. I will have many more of these visual patterns for you to look at, and let's learn and grow together. Thanks. Have a great day.